Welcome to Module MEC 8057, Mechatronics and Autonomous Mobile Robotics. I am John Headley and I will be teaching you the contents of this module. In this first video of today, we will cover what is involved in the module, what you will be learning, how the module runs, and what are the assessments. You have all opted to do mechatronics engineering. The module Instrumentation and Drives was essentially an introduction to mechatronics. In this module, we will go into more depth into designing mechatronic systems. We will apply this knowledge towards the design and control of a mobile robot, which is indeed itself an example of a mechatronic system, and then go a little deeper into the specifics of robot control. This image is from the American Society of Mechanical Engineers and it highlights what disciplines are needed to engineer a mechatronic system. If you look closely at this figure, you will see that you are very familiar with some aspects, a little familiar with others, whilst some will appear very daunting. Be aware that everyone on this module is in the same situation. For example, the students with a background in mechanical engineering will find today's topics easy, whereas this will probably be completely new for our electrical engineering colleagues. However, in the next session, we will be discussing electronics, and so the reverse will be true, with the electrical engineering students feeling more comfortable at the expense of the mechanical engineering students. The course is designed with this in mind, so although you may find some aspects challenging, it should hopefully all be enjoyable. And remember, you can ask for help at any time during the teaching weeks of the module. That is what we are here for. The module will run in a similar format to the block format Instrumentation and Drives module. All the lectures are recorded, and we will utilize the timetabled classes for you to ask me any questions on aspects you are struggling with. You should aim to watch each set of lectures before attending the classes. These videos are divided up into more manageable shorter videos. So, for example, prior to the first session, you should watch this video, called S1, for session 1, with an A, as it is the first video of the day, and then watch S1B, S1C, and finally S1D. When you then come to the class, you will then be in a good position to start on the tutorial work for that session. Note you can start the tutorial work prior to the session if you wish, and keep class time to ask me or the demonstrators for help on particular aspects. The timetabled classes are totally flexible. By that I mean you are free to do whatever work you want during them. Myself and fellow demonstrators will help you with this. There will be a worksheet to do for each of the 9 sessions. These are all optional, but I would advise you to do as much of it as possible before the next session. Specifically, the worksheet will give you a mini assignment to do. It is important to attempt this, as your module assignment will mostly consist of work from these mini assignments. If you do the mini assignments, you should find the assessed module assignment easy. I have supplied a list of tutorial questions. Solutions are given at the end of the worksheets. You should try the questions first before looking at the solutions. These questions will form the basis of the numbers exam, which will be set for the May exam period. There are also some lab-based exercises on the worksheet. It is not essential for you to do this lab work, and note that you will not be assessed on it. However, this lab work is aligned with the mini assignments, and therefore you will get a better appreciation and understanding of the mini assignment material if you complete, or at least attempt, some of this suggested lab work. I will publish all the required learning material onto Canvas, including a timetable for the classes and assessments. A discussion board will also be included. Feel free to use this to ask me any questions outside of the timetabled classes. The assignment will also be published on Canvas, but will only be available from the 3rd Friday of the module. Similar to Instrumentation and Drives, I will publish a list of demo numbers questions which will form the basis of the exam. These will be published after the module finishes, but you will still be able to ask me questions on the discussion board up until the start of the exam period in May. Note that these questions are mostly based on the tutorial questions on the worksheet, so you should try these worksheet questions in the first instance. Teaching will take place for the first 3 weeks of the module, on a Monday, Wednesday and Friday. Use the days in between to catch up on any work and to watch the videos for the following class. The final week will be kept free for you to finish your assignment. The module is split into 9 sessions. In this first session, we will look at the basics behind mechatronics and robotics, and look at options for how we are going to program our system. In the remainder of the session, we will have a look at the mechanical design aspects for our system. You will need to learn Inventor, or revise it, for this session. The next 3 sessions will look at electrical aspects of our system, in particular, designing circuits using operational amplifiers. We will test our designs on the circuit simulator Multisim, which is similar to Tinkercad but more powerful. Session 5 will look at the kinematics of robotics, and then in Session 6, we will examine sensors and data processing approaches for our robot. Artificial intelligence is becoming an important topic in many areas, including engineering, and this session will introduce you to developing your own AI solutions. Session 8 will look at how we get our robot to move around the environment, with the final session looking at control options, and then bringing together all our mechatronic design elements to complete our robotic system. The module consists of 2 assessments. The numbers exam, worth 40%, is an open book PC exam. You will be allowed to take in 150 printed pages of notes. These need to be bound in some way. The questions will be based on the demo questions available. Note that all Canvas material will be unpublished at the start of the May exam period, so be sure to have any notes you need by then. The assignment will be a video presentation of a design and control exercise, based roughly around the mini assignments you will be doing in the tutorials. This will be released on the 3rd Friday of the module, and submission will be due on the 1st Monday after this module finishes. You will need to have completed instrumentation and drives before undertaking this module. This is because I will expect you to know how to use Tinkercad, be able to program the Arduino, understand motors and how to control them, and also to understand communication between systems. These topics will not be covered in this module, but they will be used. We will also discuss sensors. I appreciate this was done in general in instrumentation and drives, but for this module we will discuss sensors specific to robotic applications and look at processing this data. You should have some experience with picoscopes and the CAD package Inventor. If your knowledge is limited in these areas, you can use the first timetabled session to catch up on these aspects. There is no required textbook reading for this module. All the necessary information is provided in the videos and tutorial notes. However, the module is based around these 3 books which you may wish to look at to deepen your understanding of the material. Both Carrier and Bolton were used in instrumentation and drives, but the topics in this module will cover different chapters. Siegwart covers the robotics aspects of the module. That covers the introduction to what this module is about. If you think I have missed anything, or if there is something you do not understand, post a question on the discussion board and I will answer it at my first opportunity. In the next video of this session, we will have an introduction into the subject of mechatronics and robotics.